Oh David, this has been such a lovely dinner.
I know, right? So tranquil. Just let me drink some water here.
Quite an interesting way for you to drink water, David.
Yes, but do you know what's even more interesting, Amanda? The definition of the term hydrogen bond.
Wait David, what are you talking about?
It's so amazing how hydrogen bond is a weak bond between two molecules resulting from electrostatic attraction between a proton and an electronegative atom.
David, why are you suddenly so obsessed with biology?
Because I am biology, and it is now my solemn duty to preach the likeness of IP Biology Unit 2.2. Now I will tell you the two factors of water that explain its properties.
David Plaza, calm down and relax.
No way. The two factors are dipolarity, group of dots, ampersand pound sign, and hydrogen bonds. NNNNG.
David Plaza, you gotta snap out of it.
Line of exclamation marks. Now I have to compare the thermal properties of water and methane.
David knew.
David, yes. Methane and water are similar in size and valence structure. However, methane is not polar while water is. This means that water can form hydrogen bonds, giving water a higher heat capacity, freezing and boiling point.
David, you have to fight whatever has possessed you. You took physics HL in high school, for crying out loud.
You can't silence the truth of life, Amanda. Water is everything.
Fight the beast, David.
I must explain why.
Why what? David. Why what?
Why the thermal properties of water is good for organisms.
David, if you don't stop, I'm going to call 911 and my local pastor.
Water has a high heat capacity, meaning it is slow to change temperature. This allows water to be used as a coolant, as lots of energy is needed to evaporate water. Sweat is a perfect example of this, as the evaporated water takes energy with it, cooling the person down. Plants also do this in their own way.
David, you are seriously pushing my buttons. Stop this right this instant.
No way. Now I must explain to you how cohesive and adhesive properties of water are good for organisms.
Actually, fine. Whatever, David.
Water's cohesive properties allow it to form hydrogen bonds with other water molecules, allowing water to have a high surface tension. This helps water molecules to stick together and pull each other up the xylem vessel in plants. Water's adhesive properties allow it to stick to other polar molecules, meaning water will stick to the xylem wall and capillary action.
Okay, David, this is getting weird. Where did you learn all this?
Who cares where? I have to tell everyone. Now I will explain how the solvent properties are useful for organisms.
David Plaza, let's just pay the bill and go home. We've been sitting here for 3 hours.
Water can dissolve polar and ionic substances due to its polarity. Large quantities of water can weaken intermolecular forces.
Did you just ignore me?
Now I will define the term hydrophilic and hydrophobic.
That's it. I'm calling 911. Okay, this is me calling 911.
Hydrophilic substances freely associate and easily dissolve in water. Typically are polar and charged molecules. Hydrophobic substances do not associate with water or dissolve. Usually are large nonpolar molecules.
Oh man, it's taking the ambulance a while to arrive.
Now I must outline how essential molecules are transported in the bloodstream.
Hurry up, ambulance. Plaza.
Molecules which are soluble in water will travel with the blood. However, insoluble substances like fats will form lipoproteins in order to move in the bloodstream. This is done by hydrophilic parts of proteins. Cholesterol and phospholipids face towards the water, outwards, while the rest are kept snug and dry.
I can hear the ambulance. I hope they can help you.
There is no need to help me. I must go now. Farewell, Amanda.
Oh sweet Jesus, David just vanished out of thin air.
Do not be afraid. I have a job I must do.
What is it? What happened to David?
I must spread the word of IP biology. I must enlighten everyone. Farewell, Amanda.
I'm crying now. This is so sad.